And this question it is given that a cube of side 10 centimeter is filled with ice of density 0.9 gram per centimeter cube. Thickness of walls of cube is 1 millimeter and thermal conductivity of material of cube is 0.01 in CGS unit. If cube is placed in steam bath maintained at a temperature of 100 degrees Celsius, the time in which ice completely melts is. So first of all, just try to understand this question. In this question, it is given that there is a cube of side 10 centimeter. So we can take it as its length is equal to nothing but 10 centimeter, and it is filled with ice of density 0.9 gram. So now we can just consider that this is completely filled with the ice, and in this question the density of ice is given. Let's say the density of ice is equal to nothing but rho, and the value of rho is also given, that is 0.9 gram per centimeter cube, and the thickness of wall of cube is also given. Let's say the thickness of this wall is given as nothing but 1 millimeter, which we can take it as nothing but it is given in millimeter, so we can write this as 0.1 centimeter. And the thermal conductivity of material is given, which is given as 0.01 and which is given in CGS unit. Now you can observe that here we are going to take each and every dimensions in CGS. If the cube is placed in a steam bath, that means the outside temperature, so it is kept in a steam bath, that means we can just take it as the outside temperature is nothing but 100 degree Celsius. RM is to find out the time in which the ice completely melts. So there will be a transfer of heat energy from each and every part of this or each and every phase of this cube. So we can find out how much is the value of heat flow through this. So we can use that equation, dq by dt is equal to Ka delta T divided by L. So ice we can take it as at 0 degree Celsius, and Rm is to find out the value of time for this process. So we can write this dq by dt, where dq is the amount of heat energy and dt is the time. So for let's say for a time of t seconds, it is transferring q amount of heat energy. So we can write dq by dt as same as like q by t. And Rm is to find out the value of time. So we can write time is equal to q into L divided by k and delta t. Now we can write this t is equal to q over here in this question. We can find out the value of q, which is the amount of heat energy to melt ice. So we can write this q is equal to mass into latent heat of fusion of ice, because by using this heat energy basically we are converting that ice into water. So the amount of heat energy required is equal to the amount of heat energy required to convert ice to water. So you can write instead of q, that is mass of ice into latent heat of fusion of ice into L divided by k and delta t. Further, you can write this mass of ice is not given in question, so you can write mass is equal to density into volume. So you can write this is density of ice, which is given in question. So density into volume into latent heat into length L divided by Ka delta T. Now again we can observe that this is T is equal to density into, now the volume of container is not given, but the length of container is given. So length of container, if you are taking it as something but L, so we can write this is equal to volume will be equal to L cube, which because it is given as cube, into over here this latent heat of fusion into this length. Actually this length is coming from this equation dq by dt by L. Over here this L is nothing but the length of conductor. Over here it becomes nothing but the thickness of that cube. So we can just take it as this is equal to nothing but T, because if you are considering the heat flow, this heat flow is happening through the walls of this container or walls of this cube. So this is basically representing the thickness T. So we can just write it as like over already for time I am just taking it as T, so we can just take it as T dash. So this I'm just taking it as T dash divided by the value of K, which is thermal conductivity, and A is nothing but its area. Now we can observe that for a cube, if you are considering only a single side, its area will be equal to nothing but L square, and such 6 phases are there, 6 surfaces are there. Heat is transferring through all the surfaces. So total this cross-sectional area through which the heat flow is happening or we can take it as nothing but 6 times of this into the value of delta T, which is difference in temperature. Outside temperature is 100 and inside temperature is 0, so we can write difference in temperature as 100. Now we can cancel this L square and L cube over here, so it's going to be L. So the equation becomes time taken will be equal to density into length into latent heat of fusion into thickness divided by K into we can take it as the value of 6 into 100. Now we can put other values also. Density is given as nothing but 0.9 and the length of that cube is given as 10 centimeter. Latent heat of fusion, we know that nothing but 80 calorie. And here remember an important thing, we are substituting the value in CGS system, all the things in CGS system, and basically 1 calorie is nothing but 4.2 joule. So calorie is not the unit of heat energy in CGS system. Unit of heat energy in CGS system is nothing but erg. So we need to write it as 1 calorie is 4.2 joule and 1 joule is nothing but remember that 1 joule is 10 raised to 7 erg. So we can write the value of this is 4.2 into 10 raised to 7 erg. So we need to convert that. So I'm just multiplying it by 4.2 into 10 raised to 7 into the value of thickness. The thickness in question we already identified that it is given as 1 millimeter or 0.1 centimeter divided by the value of K, which is given in question as nothing but 0.01 into the value of 6 into delta T, which is 100. So we'll get the answer as nothing but 50.4 into 10 raised to 7 second. So this will be the actual time taken. But in this options they are given as something but 12 seconds because they made a mistake in while developing this question. So or they made a mistake in calculation. So they just take it as nothing but unit of heat energy as nothing but calorie in CGS system. So if you are not writing this part, then you will get the answer as something but 12 seconds, but which is not correct. We need to convert it in as it is given in CGS system. The unit of heat energy in CGS system is not calorie. So we need to convert calorie into joule and joule to erg, then we need to put this value. If you are not writing this value, you'll get the answer as 12 seconds, which is not correct. You need to convert it into CGS system because everything we should write in one system. And calorie is not the unit of heat energy in CGS system. So the answer will be 50.4 into 10 raised to 7 second.